Okay, so the interesting thing about this is that rate constants are actually temperature dependent. And this makes sense. You would expect, I shouldn't say it makes sense. It makes sense to me. In my mind, if something's colder, the reaction is probably going to go slower. And I think that that's always the case. Wow, I'm going to get torched if someone sees this. Because other chemists know for sure that that is probably always the case. I don't even know. So it doesn't matter. Let's just go ahead and do it. We know that we know what the rate law is, but we don't know the temperature dependence at a colder temperature. So let's do this. Let's come over here. Let's say the rate law is this. Get a little sloppy there. And we know it's first order with respect to all three. And since it's first order, we don't usually write the ones. Let's go ahead and say iodate, hydrogen sulfite. Oops, that was sulfate. Hydrogen sulfite. And sulfuric acid. Okay. Now, we know for trial 5, it was a different temperature, right? And so this is not going to be 239.65. No, it's not, because it was cold, and K is temperature dependent. So let's go ahead and figure it out. K then, and we can do this pretty easily because I'm very comfortable with my algebraic manipulations. K is going to be the rate in trial 5 times the concentration of these things, each in trial 5. Right? Well, I remember trial 5 because I had the same concentrations as trial 1. So I'm going to go ahead and fill those in, and then we'll go look up the rate. The rate in trial 5 I don't remember, but I remember that the bottom, that was pretty ugly. Let's do it like that. And it was 0.004 in all of them, okay? So I'm going to say 0.004 times 0.004. I know what you're thinking. It's just cubed. I get you. Okay. All right. 0.004 cubed, basically, right? And let's go look at the rate in trial 5. It was different because it was colder. That was in question 3. It was 1 times 10 to the negative 5 molars per second. Okay. So it was 1.00 something. I forget. Let's go back up and look. Sorry about that. All right. 1.003 times 10 negative 5. And this was in molars per second. And this down here was molars, molars, and molars. I'm just going to say molars cubed. Okay, so the result then is going to be molars divided by molars cubed. It's going to be something molars, right? Because if you put all those together, that's what you get. Okay, this is really 1 times 10 negative 5 divided by, oh, I can do that in my head. This, you know what? I'm going to play a little game here. Since it's a video, this is the same thing. 0.004 is the same thing as 4 times 10 to the minus 3, okay? And so 0.004 cubed is equal to 4 times 10 to the minus 3 cubed, which is equal to 64 times 10 to the minus 9, right? Okay, which is equal to 6.4 times 10 to the minus 10. No. 8. Right? Because if this number gets smaller, that number is going to get bigger. Okay. So it looks like it's really, this is the same thing as 1.003 times 10 to the, I can't resist doing this little math game with you guys because somebody's going to recognize times 10 to the minus 9, right? That this gives you power. So 1 over 6.4, and this is going to be times 10 to the 4, right? Because this is going to come up top, times 10 to the 4. Well, 1 over 6 is 0.16, so 1 over 6.4 is going to be smaller. I'm going to say this is about 0.15 times 10 to the 4, which is the same thing as 1.5 times 10 to the 3, right? If this number, if that part gets bigger, 1.5 times 10 to the 3. Okay, that's bigger rate constant. Wow, it should be smaller than the other ones. I'm sure I've got a mistake here somewhere. I've got a mistake here somewhere. This is probably where it is. 64 times 10 to the negative 9 is 6.4 times 10 to the negative 8. Ah, there it is right there. I put 6.4 times 10 to the negative 9. It's really supposed to be 8. That was my mistake right there. Times 10 to the minus 8, right? Okay, and so if that's true, this is going to be 10 to the 3. This will be 10 to the 3, and this will be 10 to the 2, 150. Yeah, that makes sense. Because it had to be smaller than the other k, because it was colder. All right, and it'd be amazing if you guys were thinking so clearly that you could see that from where you're sitting, but it is just math that I'm doing right there. All right, so let's go back and do this now. I'm going to go 1.003 times 10 to the minus 5 divided by 0.004 raised to the 3. And sure enough, 158.72 or 156.72. And I said that, and my estimates here was about 150. 156.72, yep, legit. 156.72. Okay, this was just an estimate. And I got 150. Here it is. Great. Done with that one. A little bit extra for that video for your trouble. I hope that's helpful.